In this first video, we're going to introduce the cast of characters for this course. And really, they're not very many. They're just the basic fundamental building blocks that we're going to use to make up atoms and molecules and learn about quantum mechanics. And so really, there are only three things we have to deal with, but we're going to learn really quickly that things will get kind of interesting from the get-go. Now, one of the basic properties of quantum mechanics is what we call wave-particle duality. We're all used to thinking of things in kind of two different ways. We can think of little chunks of stuff that we call particles, a little ball, a pool ball, a marble, an electron, a nucleus of an atom, and we put those in one category in our mind. And then we think of other things like waves, like ocean waves, sound waves, electromagnetic fields from Physics 2, if that fills you with joy. All those things we're used to thinking about as oscillating large-scale systems, a string on a guitar that have this wave character. And it turns out in quantum mechanics, it's going to wind up being really, really important that all of the objects we look at actually are a little bit of both. So they can be particles under some circumstances, and they can have very exact location. We can find them in a certain spot with a certain amount of mass, for example. And in other circumstances, they kind of blob out and spread out and have this wave-like behavior. And in fact, that thing that we call the wave function is the central feature of quantum mechanics. This course has three heroes, and we're going to build everything around these three fundamental building blocks. So the first of our three heroes is the photon. That's essentially particles of light, and of course those are light waves as well. The second hero is the proton, essentially the nucleus of a hydrogen atom. And the third hero is the electron. Of course, the electron orbits the nucleus to comprise atoms. And eventually we're going to have electrons interacting with electrons, and everything is going to get kind of fun. So with just those three simple things, we're going to build up all the main features of first quantum mechanics and then ultimately chemistry. We're going to deal with the structure of atoms, the structure of atomic orbitals, energy states of atoms. We're then going to deal with how electrons interact with each other in multi-electron atoms, and finally see how different nuclei and electrons can combine together to make chemical bonds. And that's it. That's everything we're going to do in the class. Now for these three heroes, there's 6 properties that we're going to need to understand to really identify and play with how these heroes behave. Some of them are pretty normal: mass, charge, speed. Then we get a thing that we're going to call spin angular momentum, which is a pure quantum mechanical property we often call spin. Everything, as we'll see, is going to have a wavelength because it's wave-like. And then since we care about the particle behavior of things, we're going to find out that momentum is also a critical parameter for all the compounds. And once again, that's basically it. So we're going to have 3 different fundamental objects in the course, and 6 properties for those are going to define basically everything we need to know about them. So our first hero is the photon, the particles of light. Now for the mass of the photon, photons have no mass. Good. Light doesn't have mass. The charge of the photon, photons carry no charge. Q is equal to 0 as well. Now the speed of the photon, of course, is the speed of light in a vacuum. C is the indicator, and that's 2.998 times 10 to the 8 meters per second. And you really ought to know that number. 3 times 10 to the 8 meters a second, 3 times 10 to the 10 centimeters a second. Now things start to get a little interesting. This thing called spin, photon turns out to have that. It has a spin angular momentum what we call the quantum number that we'll learn about later is 1. And that makes it a special thing called a boson. But just keep that in mind. We'll learn about that in a couple of months. Next, the photon, of course, has a wavelength. Light has a wavelength, and it can have any wavelength. For light, that defines its color. That's a fundamental defining characteristic of different photons. And finally, believe it or not, photons do have momentum. Even though they have no mass, the momentum of a photon is the absolute value. The magnitude of the momentum is defined as this thing called Planck's constant h, which we'll see a lot of in this class, divided by the wavelength of the light, the wavelength of the photon. If that seems strange, it is, but things like light sails actually do work. You can bounce photons off of things and they get momentum. I know people who have been in the way of carbon dioxide lasers, fortunately with some sort of shielding, and when those things go off, very high-powered lasers, you can actually feel the impact of the light as it strikes you. You might do that as a calculation in the class. So photons actually do carry momentum, and we measure it in this way. We're going to see a lot of this particular formula. Our next hero is the proton, the center of the hydrogen atom. Now the proton has obviously a mass, and actually we call that mass one atomic unit. We're going to use these units that we call atomic units as opposed to the standard MKS units that you're used to, because the mass of the proton in MKS units is 1.67 times 10 to the minus 27 kilograms. And that's just a ridiculously small number. One atomic mass unit is a heck of a lot easier to remember, so that's what we're going to use for that. Of course, the proton has a charge. It's positively charged. Once again, the charge that we're going to use is plus one fundamental charge that we call E. And again, that's actually 1.6 times 10 to the minus 19 coulombs, a tiny, tiny number, hard to remember. Plus E is pretty easy to remember. The proton can have a speed. It'll be moving around, and the only requirement is that speed be less than the speed of light. Nothing can go faster than light. The proton, excuse me, does have spin, and it's a spin 1/2 entity that we call a fermion. The photon had spin of 1. The proton turns out to have a spin angular momentum quantum number of 1/2. And again, we'll learn what that means and what the significance of that is, which is really actually kind of huge later on in the course. Once again, even though the proton, we think of it as a particle, it can and does have a wavelength, and that wavelength is given by the exact same formula we saw for the photon. The wavelength is equal to Planck's constant divided by the magnitude of the momentum of the proton. And finally, from a classical perspective, the momentum of the proton is given by the mass times the velocity of the. Okay, so the last of our main building block heroes is the electron. The electron in a lot of ways is my favorite. It also has a mass. The mass is a lot less than the proton. So in our atomic mass units, it's 0.0000%, 0.0005 atomic mass units. The charge of the electron, of course, is the exact opposite of the proton, so it's a negative fundamental electronic charge. Once again, the electron can have a speed less than the speed of light. Tends to go quite a lot faster than the proton, but it still can't go faster than light. Just like the proton, the electron has a spin quantum number of 1/2. Again, we'll learn what the heck that means, making it a fermion later in the class. Again, the electron has a wavelength, and just like everything else, that wavelength is given by Planck's constant divided by the magnitude of the momentum. And again, as a semi-classical object, the momentum of the electron is given by the mass times the velocity. Now the electron really is sort of the special hero of this class, so we'll give it some extra attention. Electrons are really light. That's really a fundamental property of them. Again, the mass of the electron is about 0.05% of the mass of the proton, and that gives it some special, very quantum characteristics, as we'll see. We're also going to talk a lot about two very special electrons. They're good friends of mine. They have names. One is Clarissa and one is Juan. Now, some things about Clarissa and Juan. They really don't like each other at all. They actually despise each other. That's going to be important. Because of their mutual enmity, they have a strong tendency to avoid each other. And we call that electron correlation. It has a great deal to do with the properties of atoms. Then finally, sadly, we're going to learn that actually you can't tell the difference between Clarissa and Juan. We can't tell which is which. And oddly enough, the fact that we can't tell them apart turns out to be incredibly important and has everything to do with the fundamental nature of the way the universe exists, just because you can't tell Clarissa from Juan.